My name's Paul Parkinson. I'm the data and transaction processing dev lead at Oracle for the last 17 years or so. So in middleware space and now in the cloud space. And Kuassi and I have worked together for about that long. He's on the database side. And so we're going to co-present this Microservice Essentials focusing on data and transaction patterns. So I'll start off and do the first half of the presentation, which I've been coining as kind of the good news, all of the great new technologies and microservices, things like that. Kuassi will go into, the additional considerations and things like that in data and transaction in microservices world. And then I'll do a 7-minute demo kind of showing off some of these patterns. So this is the usual safe harbor statement. And this is the agenda. So very quickly, just a show of hands, people that have done just any kind of work in Kubernetes or microservices. So, okay, cool, excellent. So you're probably familiar then with this, the world of cloud native computing foundation. So I'm not going to go into all of these, but going to go into some of the aspects that are most pertinent to microservices and data manipulation in particular. And so hopefully everyone's pretty familiar with the concepts and advantages of containers and Docker, all the scaling, modularization, things like that. So now that we have everything in these containers, we need an efficient way to orchestrate them. And Kubernetes has really come to the forefront in this area. So this, brings us all these advantages as far as velocity for constant updates. Declarative API is a huge one. You just kind of label your services and deployments with their requirements and let the service drive to that desired state over time. And Kubernetes takes care of all the how as far as your infrastructure needs and things like that that you've declared. And of course, the aspect of auto-scaling. So one of the reasons that makes it ideal for microservices are these reasons here. And to be honest, I described some of the resources in Kubernetes, and I think they kind of naturally explain why it's great for microservices. So some of the main resources in a Kubernetes environment are the deployments. So these are your images and the descriptions of what's needed for those deployments, the environment, et cetera. The pods, which are your runtime processes for those deployments, and this is what you'll use to scale and things like that. Your services, and this is so many advantages of Kubernetes, but this is a beautiful aspect where your networking is abstracted, and you give your services these logical names. So you have your load balancers plugged in via these services, and then you can access your deployments via these services with just logical names, as we'll see in the demo. Secrets are a Kubernetes resource for encapsulating credentials and things like that for connecting to various resources such as ATP database that we'll see in this demo. And namespaces are just kind of a logical way to separate your work. So this can be used in any form, different subsystems, different applications, and these are great ways to develop microservices. For example, when we were doing demos even for some different conventions this month, we weren't sure how much we were going to add and things like that, so one developer was working in a separate namespace, and if we wanted to show off certain aspects of like held on SE, for example, we can just access a different namespace but work in isolation. So describing the resources, I think, helps describe the advantages. So now we have the containers running in Kubernetes, and Oracle is providing this, on top of this container native platform, providing all of these services for these, added services for these microservices that are running in Kubernetes. And so, registry, object storage, things like that. One such resource, which is pertinent to our discussion today, is the Open Service Broker standard. So this is there are a number of standards coming out, and so we are actively contributing to and latching on to some of these, to the standards that are clearly going to be the way forward. And as far as accessing services, cloud services from Kubernetes, this open service broker spec is what's used. And so we just this week are announcing the release of the Oracle Service Broker to allow you to attach to Oracle database services such as ATP, streaming, object storage, and things like that. And so what this will do is it's a very easy mechanism where in your cluster you'll just add your OCI credentials and make about 3 commands, and you've provisioned an ATP database and created a secret in your Kubernetes environment. Your application just references that secret as we see on the right, and then you have connection to this database. Extremely simple now, and then we're adding this to the marketplace where literally you'll click a button and you have access to, provisioned and access to an ATP database. So it's really nice. So we see a deployment YAML example to the right here in Helidon, which I'll get into a little bit later. And we see that the secrets that were created are brought in as environment variables, and then your Java application can just access them. So however you want to do it, that's a simple way right there. Another standard in the microservice space is the CloudEvents specification. So communication in microservices, we're in an async world now, so it's all event-driven. And so the standard format that has come about for that is the CloudEvents specification, and so all our products are supporting that. Another sort of de facto layer on Kubernetes is really powerful technology called a service mesh, and Istio has come to the forefront as the big service mesh implementation. And so basically what it does is gives you all these cross-cutting concerns that you see here, provides them to your microservices, so you don't have to code these into all your individual microservices. It brings it up a layer, and since it's common to all microservices basically. And so what you see here is your Kubernetes cluster on the left. These are all your pods, your runtime pods. And you just make a simple, you can configure it at different levels, but you can just label all the pods in a given namespace and just say Istio enabled equals true, one command. And the Istio system will inject these sidecar pods. And they're basically interceptors for all of your pods. So any traffic coming in and out, this interceptor, using the sidecar pattern, and in the case of Istio, this is the Envoy. Envoy is what's used for the sidecar. It's adding all this quality of service. So here are some examples of those services that are given. Certain different routing rules. So your deployments as far as green, blue, canary, mirror shadowing, so you can send duplicate traffic to production and your QA environments. Security, mutual TLS between these nodes, bringing that, again, out of your application into this layer above. Resiliency, this has actually been a huge one for testing, especially, I'm going to enhance the demo, actually, to show this as far as data manipulation. But you can configure circuit breakers and things like that for behavior in your application. If you're getting too much traffic to this one node, or you're getting, you can really define it down to a fine level. If I hit, a 500 error on this service 4 times, then redirect to this service or start doing, all these various actions. You bring it out of the application. So really nice for just runtime behavior and for testing, because you can inject these different faults. And then telemetry tracing. This is actually, in a way, my favorite, because this is something, with all these difficulties, we've have these additional considerations and difficulties in data manipulation with microservices. This is something we didn't have in the past, which is this really nice tracing of calls through the system, and along with calls, transaction behavior. And so even though Istio is nice because it brings it out of service, some of the configuration can be tedious, so we've come out with some annotations for services where you can just, and here's an example here, as far as routing rules, you can just use these annotations and it generates everything for you in Istio. So very easy and very handy. And then this is a Kiali tool which feeds off of Istio and Jaeger tracing information to show you this call graph that I was mentioning. So it's very nice. You can see the call graph, workloads, it's versioning, et cetera, of your microservice topology. And then from that, you can drill into the tracing. So the standard for tracing is called open tracing. And products such as Zipkin and now Jaeger's, a little bit more to the forefront, provide this tracing. And so what you see here is we have support for tracing. And in this application case, it's WebLogic calling Helidon, calling the database. And you can see it in a single trace and all the information related to that. You can trace it all the way through the system. So this is, if you're debugging transaction data issues, this is great. And then the two aspects of open tracing essentially come down to baggage and tags. So baggage is propagated through the full call of your trace. So that'll be like your transaction ID, things like that. And we're adding tracing to the database, so it will go all the way from your front end, all the way through all your systems into the database for tracing. So it would be, very nice for debugging. And then the other aspect is tags, which you can attach arbitrary information to. And that's collected async, so that's generally your performance analysis between the systems. And then also from that, you can drill down into Grafana for time series data. I'll just mention that, if there are any WebLogic users, we've created, it's been out for a while now actually, a WebLogic operator. So this brings WebLogic into the cloud very easily. The operator takes care of, an operator is a Kubernetes type of resource that basically acts as an admin. And so this is our way that we brought WebLogic into the cloud, very simply by letting people use this operator. And then the forward-looking platform is called Helidon, and this comes in two flavors. The first is a pure microservice framework called Helidon SE, and this is more of a functional style async reactive database access. Kuassi will talk about this a little bit. And it's transparent, meaning it's more of a direct API access versus, say, CDI or things like that. It's a direct access. So this is the pure microservice platform. Helidon MP is meant more for Java EE customers. I don't know why that keeps going forward. But it has all of the functionality, basically, of Java EE and the annotations and things that you're familiar to. So if you're coming from WebLogic or something like that, a Helidon MP is, it's exactly made for that mapping. And then just wanted to bring up the fact that we've done and continue to do a lot of integration as far as the Oracle products. So we have the tracing and Saga and AQ support that Kuassi is going to talk about in a little bit. So I'll relent to this slide and let you take it from here.
I'm sorry, not my doing. Okay, so I'm going to talk to you a little bit about data management with microservices, and then transaction management with microservices. So data management is sort of the hard part of microservices. Okay, so the guiding, what you need to use to guide you in the design of data when you're using microservices, or even if you're migrating a monolithic to microservice, you need to pay attention to what is called bounded context. And this is a term coined by Martin Feuler, one of the authority in the IT world. And essentially, it is a space where you can design your microservice in a way to minimize sharing across microservices. You probably hear the term that each microservice needs to have its own database. This is sort of the extreme vision of the world, but what you want to do is minimize the sharing of data between microservices, and the way to achieve that is to base your design on bounded context. So, for example, you want to split a monolithic database along the lines of the bounded context, and you can see the pictures of those bounded contexts over there. You have the sales context and the support context. You might have some minimal sharing. It's not like a completely separation, but you might have minimal sharing across those contexts. Okay, so that's the principle that will guide your data design in microservices. Now, how do you deal with data in microservices? Well, you could have a database per service. If you take the the recommendation to the literally. Okay, I work for Oracle, but everything I say can be applied to any database vendor. So from Oracle, we have what we call Pluggable Database. So it's think about a container where you can plug your USB, for example. One container can manage multiple databases, and each of them is a full-fledged database, but the infrastructure to manage the database is shared. But data is completely separate. Each one has its own database. So that's called Pluggable Database. You could use that. You could use shards. Shards, everybody knows about sharded databases. You could use shard. You could do more advanced sharding on that. So, the other approach would be to share databases at table level, at the schema level, or at what we call in the Oracle world the edition level, which is sort of versioning of your schema. You have a schema at V0, and then you can modify your schema at V1, for example. So a microservice A will be using the V0 of the schema. Microservice B will be using V1 or V2 of the schema, where you have more columns to your table or more semantics. Anyway. In the same database, yes. And then you have this notion of polyglot persistence. I will talk about that. And then API composition. This is for queries. If you need to query, you have one service, which is the front end, and which will query data from all those services. From my perspective, this is reinventing the SQL from the database in the microservice world. So I personally would not recommend that. And then we have CQRS. I'll talk about this later. Okay, so private database, that's just the schema. You have each microservice owning his own database. However, when you want to scale, for example, queries, if you know that this database is only queried, nobody makes update to that database, you can use it as a materialized view, and you can have multiple copies, so you can scale the reads on those materialized views. And this is something you might use for a catalog, for example. Everybody comes and browse your catalog, so you might have multiple copies of the catalog. Whereas transactional store like order service or customer service, those are only one copy. And here is another example where you can share databases, and the picture on your right is showing that we can have multiple data sets, and each microservice has its own data set. So there still is this sort of isolation between data set, but the database itself can be shared. You can share at different level, as we were saying before. So you should not take literally the term that each microservice needs to have its own database. This is just to show you one example where we can partition a PDB. We can shard the PDB across multiple containers. This is very important in countries where they say data must be local. Even if the database is in the cloud, it must be local in the country. So in that case, you could have one shard in Germany, another shard in some other place, but it's the same pluggable database. But you have a different vision depending on where you are. Anyway. Okay, so now I'm going to talk about data model. Okay, so microservices, the reason they say each microservice has its own database is predominantly because each microservice might be managing a specific data model. For example, JSON. Okay, so one microservice is only manipulating documents, so you want to have a JSON database. Another one is manipulating images. Another one, relational database, for example, relational model. So that's one of the motivation where they say each microservice has its own database. So this way, you will have one specialized engine per date model. For example, MongoDB for documents, and what is the database for graph? Neo4j. Neo4j for graph, for example, and MySQL for relational. You could do that, but there are consequences and there are issues on that. So that's the model I'm representing here. But you can also have another model where you have the same engine capable of dealing with multiple data models. And you guess this is the Oracle model. So, well, I'm not trying to sell you Oracle, but I'm telling you what it is. What it is you have the engine which can manage multiple data models. The same engine can share JSON documents, can share graph documents, spatial document, graphic, text, images, and relational, which is the original. So it's a choice. It's not like one is better than the other. It's your choice. However, for example, when you want to represent something such as a catalog, if you go to Amazon or the other vendors where you browse the catalog, a catalog is made of not just the description of the product, the image of the product, and different models. So a catalog is built using different models. It's not just one model. So if you have one specialized engine which can only deal with one data model, how do you build a rich catalog? So those are some of the issues that you want to consider when you want to pick an engine to address your data requirement in microservices. Okay, so this is forward-looking. As we say, you want to have the less sharing possible across data set. So you need a tool. For example, if you're migrating a monolithic database to microservices world, you want a tool which will help you isolate data access so that you have the least sharing possible between microservices. In other words, you want a tool which will help you isolate your bounded context at the database level. So the Oracle database the tool is not out, but we've been working on that. It's called the SQL tuning set. It doesn't have a name yet, but it creates what is called a SQL tuning set. So we give you some script, you run your workload, and from that we can identify which table are being accessed by which module. And at the end, we can generate a graph which tells you, this is the cluster of data which has been accessed by X, Y, Z. And this way, you can split, you can partition your monolithic with confidence because you know that you have identified the isolated data accesses, and you can deal with the few areas where data is being shared across microservices. You can deal with those. So, but the tool is not out, and there are other tools, other third-party tools to help you do this kind of determination of who is accessing the data, how can I split my monolithic, or how can I make sure that microservices are not sharing data, not sharing too much data between themselves. Okay, I'm going to talk a little bit about transaction management, and then Paul will give you a nice demo which summarizes everything we've talked. Through the demo, you will see in real life what we're talking about, because we talk, but it's not easy to grasp in your mind. Anyway, so microservice. So literally, an application is a collection of microservices, right? Okay, now how do you communicate? There are many mechanisms where you can use for microservices to communicate among themselves. You could use file system, one write, the other read the file system. I don't know who's going to do that, but this is a possibility. You could use databases. You could use remote calls. Or you could use event, which is what the industry has sort of settled on. Everybody is using event-based communication between microservices. So So there are, the beauty of event communication is it's a pub-sub, the publish, subscribe, notification, asynchronous. I don't have to have the corresponding microservice up and running to get my notification. I just emit my notification. I persist the event in the event store, and the microservice, everybody who subscribed will receive the notification and will process the event when they can, when they are capable of doing that. So it's asynchronous. You don't have to be sort of synchronous and waiting for the other guy. Immutability, the event store is the source of truth. So I can go back in history and replay the event and come back to the same situation. So there is no change. Once an event is persisted, you don't change. No change to the event when it's in the event store. This way you can do lineage, you can go back in history. Anyway, so there are two patterns in the event communication. One is called the event sourcing. It's very popular. And the other is CQRS, which stands for Command Query Responsibility Segregation. So very quickly, I'm watching the time. Event sourcing means one service writes the event in the event store, and the other read the event from the event store, right? So you write in, the consume. In this example, you can see that the order service is persisting the data into the database and persisting the event into the event store at the bottom of the slide. And then the inventory service will get the event from the event store and do something about it. For example, he can write data into the database, which is on the other side. So you have producer and consumer of events. Okay, very simple. Okay, CQRS is more complicated than that. I mean, the complication is that, it serves multiple purposes. The first purpose is you separate responsibility. For example, some microservices cannot make changes to the data. They can only, they can make changes. So the commands can make changes, do not query. Queries can view, but do not change the state. They do not change the state, the state which means the database, right? So the queries can also be used to gather data from multiple sources so that you don't have to go back to the database to get the state. I think Paul has that in the demo. So you will see an example of CQRS to sort of coalesce data from different sources. You usually combine CQRS and event sourcing, okay? So it's not like one or the other. You usually combine, and you can see that to scale the read, you can have materialized view or in memory so that the reading the orders can be faster. Looking at the time. Okay, so here are some issues that you will face when you deal with microservices. That's what Paul was alluding to when he said Kuassi will tell you the bad story. Well, the complexity in microservices is, this is one example. I need to persist the event, and I also need to persist the changes to data in one transaction. Forget two-phase commit. Nobody's using two-phase commit anymore. So how do you do that? How do you persist the changes to the database and the event into the event store? They are not the same database. So local transaction, won't work because it's two different stores. And we don't want to use two-phase commit. So there are different approaches to deal with that. One is you could use a database as a message queue. So you use the database as the event store, but this way you are reinventing a mechanism I will talk to you about, which is the Oracle Advanced Queue, which is the in-database messaging system. The other is turning the database inside out. So this consists in publishing an event and listening to your own event. When the event comes back to you from the broker, you can update the database in reaction to the event. So you sort of separate the persistence of the event from the persistence of the database. And then the other technique is called outbox, where you tell the transaction log. So you persist your data into the database, and now you read the transaction log. There are tools to do that. So you tell the transaction log, and from there, you publish the event to the message broker. And the last technique or last approach is to use Oracle Advanced Queuing. Okay, so this is the outbox approach where you consume the event. So the microservice receives the event. It will insert a data into the table. This is the state. And then at the bottom of the slide, at the database on your right, it's have a table called the outbox. And this is mining the transaction log and publishing an event. So you insert a pseudo event into the outbox table, and you mine the log and you publish the event. So it's sort of a little bit tricky, but it works. And there are some vendors who do that, but it is complex. This is the AQ approach. So AQ is an event store. So you have your data, your state, and the event in the same repository on the same command, the same connection can be used to address both. So it's a local transaction, no two-phase commit, no nothing, so it works. So that's a possibility. Okay, that's what I just said. Okay, it's simple, etc., etc. Okay, moving on. So what you can do today, if you were to use advanced queuing in Oracle, is you could have queue operation and event in the same local transaction. We can shard the queues. You can do all sort of mechanisms that a queue provides, such as high availability, for example. Anyway, I'm not trying to sell you anything here. No, I'm not selling at all. I'm just telling you what it is. So, okay, so transaction management. Well, use the same mechanism, the local transaction within your bounded context. That's easy if you can do that. However, sometimes transaction might span a microservice. It might be across multiple microservices. So, for example, if you're booking a trip, you need to book your flight, you need to book your hotel, sometimes you need to book a car, you need to book shows, you want to take your wife to show or your husband to shows. So what happens if one of the steps fails and you need to either go back to the previous step or cancel the whole thing? Because remember, each step is an individual and atomic transaction. You commit. It is committed. You book your flight, you commit. You book your car, you commit. You book the hotel, you commit. But one step fails and you need to revert back. How do you do that? While there are many complexities to do that, usually the traditional way people address that in the microservices world is you write what's called compensation function. So you do the opposite, right? But sometimes you cannot do that. Sometimes you cannot undo what you have done. But that's the mechanism that people use predominantly today. So you write your microservice, but you also need to write the compensation functions. So it makes the programming a little bit complex. Okay? So you hear about this pattern called the Saga pattern. This is a workflow. It's a sequence of local transactions. Each transaction makes changes to the state, to the database, and publishes a message or event to trigger the next local transaction. Now, if one fails, how do you compensate? That's what I just discussed, and this is the representation. And for time's sake, I'm going to go a little bit faster here. You have multiple approaches to Saga consistency. One is choreography. They communicate between themselves. They don't need an orchestrator. Or the other is an orchestration where you need a master to orchestrate. This is business process management software to do that. So now the problem is, what if my database is smart enough to compensate the transaction, the Saga? Saga is a series of local transactions. One step failed. If the database is smart enough, it can do that. It can compensate. It can undo what I need to revert. Okay, so that's called the Saga. And we're showing you here, and I don't really have time to go over the code. Well, this is no Saga support here. This is just comparing plain Java code on the left to Java code using advanced queuing in Oracle on the right. And you can see that on one hand, you need to deal with sending the event in a separate function or separate transaction, whatever. On the other side, everything is in the same local transaction. Now, if we add Saga support, you can see that on your right, we have this Saga begin keyword and Saga commit at the end. So that's how we tell the database this is a series of Saga, and if I roll back one, the database knows how to compensate. I don't need to write code to do the compensation. Okay? So I'm giving you more where we putting into consideration the event, processing, dealing with the duplicates, something you don't have to do if you were using AQ with Saga support. And last but not least, this is using the Helidon notation. Helidon is sort of a framework, Java SE framework. You can compare that to MicroProfile in Spring, for example. Okay, so that's what we're doing. Last but not least, before Paul shows you the demo, we're also looking into reactive database access, where you will have asynchronous and reactive microservice database access. Okay, I think that's good enough. Paul, it's your turn.
Okay. Let's see.
It's this one. Right.
Cool. Yep.
So you want green.
Cool. Okay, great. So hoping I don't get any groans. This is a recorded demo just for time's sake and because there's a lot of information in there. But I can definitely show this live. This is running. I can show you code and things like that. So just let me know, afterwards if you'd like to do that. So it's a basic online store, school supplies. I'm going to show off the different data models and patterns and transaction patterns. So the first thing we'll do is show the fact that Oracle Database supports GraphQL. And so that GraphQL will give us all these related results from different data sources, tables, et cetera, in one REST call. So it collates all this information and works well with machine language or machine learning. So you can see if we searched on a pencil and a high rating from one of the tables was the school supplies company, we might get related products like a pen as well. So it's just showing that kind of data model. Then next we'll show a shopping cart that uses JSON. And so we'll add the pencil to the cart. And then we'll go ahead and look at the source. And all we're really showing in this source is the fact that we're using this Oracle SOTA API, simple data manipulation API. And so the main point I'm trying to make here is that we're not doing any SQL whatsoever. We're just accessing this SOTA API and manipulating JSON directly, and it's being stored in the database. So this is, again, using JSON as a classic microservices, or using JSON to manipulate data in this way. Next thing I will show is submitting an order. So this gets into our data and transaction patterns because I'll be showing event sourcing and a choreographed saga between the order service and the inventory service. So we'll place an order, there won't be enough inventory, so the order will fail. So we're expecting a failed order here because this choreographed saga between the order service and the inventory service has a contract in that way where if there's not enough inventory, the order fails. So we see failed order status. So we'll go over and look into what happened when we placed that order there. So we'll look at this Kiali tool I brought up earlier, and we can see a visual of this application, so it's nice and laid out. And we can see access of our front-end shopping cart to the inventory service, order service, et cetera. It also shows off versioning. For example, we're versioning off Spring Boot into Helidon. It can show that communication. This is actually animated as well to show workflow. But notice there's no direct communication between the inventory and order service. So the nature of microservices is async, and we're not doing this direct service-to-service communication. We're using event sourcing that Kuassi described. So each service is sourcing events for its data and its communication. It's not, these services are not communicating between each other. And so what we'll see is when an order is created, it creates an order and publishes that event. And we're going to go into the source code after this and look at it in more depth. So it's inserting that order, it's sending the message, and then the event store is, as Kuassi mentioned, is that source of truth. So if anything fails along this way, a service completely drops off, whatever the case is, it comes back up, tells the event store, this is where I want this place and time, whatever, brings the service back up to speed, like kind of hydrates it in a way. So the inventory service receives the order event, and it checks its inventory. And it does so via this event broker mechanism that we talked about from the event store. And then when the inventory service sends its status for that item, the order service receives it and then updates the status. And if it failed, it compensates by setting that order status to failed. So that's the very simple compensation activity in this saga here. Now, this is the most important, probably one of the strongest features in the Oracle database, and this I do have to point that out, is the fact that you can actually get the JDBC connection from the JMS session. So that's very unique and just a great feature that, this has been around for 15 years, but it's perfect for microservices. So we kind of like got, lucky in a way. So you can, in the same transaction, insert your order and send your message. And so it's an atomic operation, because if with something else, some other solution, one may happen and not the other. And so we're sending these events in that cloud event standard that I mentioned before. So now this is our inventory service receiving that order placed. Here we're doing a dupe processing check. So just pause it super quick here. So again, the same rule that's kind of like these hard, fast rules where one database to one service. Well, the idea is to encapsulate and isolate. That's not, like the hard rule. The other rule in microservices is, your services have to be idempotent. You have to write them that way. Well, that's easier said than done as well. So if you're using something like, a database and Kafka where it's non-atomic, you may be getting dupe requests. And, yeah, you're supposed to write your microservice to handle these. But that takes some recovery code. So if you, again, I'm just contrasting the two. If you have AQ, you're getting an exact once message delivery, and you wouldn't need to do this is dupe logic. So the inventory service is checking whether that item exists and adjusting the inventory accordingly and sending a message of inventory failure in this case because the inventory does not exist. So the order service receives that. I'm just calling out here that you can have multiple events for any multiple reactions for any given event. So if this was a successful sale, you might also get a suggestive sale event. And so it's kind of nice you have these different quality levels of events. If we lost the suggestive sale event, it's not so bad. If we lost a transfer event, it is, and we can have these different levels. So now we go ahead and we're just going to add inventory and see that there's a successful order that's placed. So now we see the successful order. And we're going to go ahead and do a show order. And this is going to show off CQRS, the Command Query Responsibility Segregation. So as you saw when we were doing inserts of the order, we're doing straight SQL inserts into the database. Meanwhile, all those events that we've been publishing are collected by interested parties. So the order service has been listening to inventory events, suggestive sales events, shipping events, things like that, just picking off what it's interested in. And so when we go to do something, a query such as show order, that service has built up all this information on that order, and it doesn't need to go into these other databases or other services to get that information. It built it up locally. And so that's the nature, of event sourcing in CQRS. Yeah, right. So that's, it will not persist. It'll be in memory, but if it fails, the recovery mechanism there is to go to the event store and say, this is where I left off, or bring me up to the latest state. It will send those events back, and then it'll build it up that way. So yes, it is persisted, but in the event store, not in the local database.
What component is restarted? How do you know which events is to be loaded with events?
That's what the, when the service comes back up, it'll call the event store and say, these are the events that I care about, and they'll be replayed. And there's ways to make that efficient so you're not replaying, the history of the world. And that's another thing that AQ, has built in. So, but that's a key question, exactly. That's a key part, because these services, microservice nature is they could be coming and going, so you design for the failure. And so, a lot of these systems, not to tangent on that, but we'll build in this chaos testing where they'll, actually during runtime pick off these services to make sure they're pulling from the event store to rebuild that information. Yep. Yeah, that's a great question. Perfect.
So since this is the last session, I was hoping they can allow us to take questions even if the time is up. I don't know. So any question? You have any question? What was
Share
the
the
question?
slides.
We can share, but we have to remove things that have not been available as a product because, it might not happen, who knows. This is the Oracle policy. I cannot give out material with contents that has not been released. So we will publish, but we will remove some of the slide. Yeah. Okay. Thank you.